Thank you.
Okay. So today we shall be continuing our lessons. And today we shall be going into further detail of what we learned yesterday. So first, as an example, we shall review slightly what we learned yesterday, and we shall try to do this example. Okay, we shall quickly do the problem. So the idea is that we can just simply write everything out because let's say we have the two matrices that are diagonal. So that means that one of them would be something like A1, 0, 0, 8, 2. And the other one would be something like B1, 0, 0, B2. It turns out if we multiply this is gives a diagonal, the matrix that's A1, B1, 0. And so this is also diagonal matrix because there's also like two zeros here. And that's very simple. And so that's how you do it. And we may move on to the next question. Okay, for this problem, I think the best way to do is we can just write it out again. For example, let the matrix A be equal to A, B, C, D, right? Then matrix C will be doubling the entries in the first row of A. So that would be 2A, 2B. Then the determinant of A and the determinant of C will be. We can notice that this is 2 times AD minus BC. So hence we have that determinant of C is 2 times the determinant of B. I mean 2 times the determinant of A. Sorry. And so that's how they are related. DM to me the one with the koala. Okay, we may move on. Yeah, this example. Okay, this is like actually a very important fact of like determinants and how you can compute determinants. Uh, and the reason is that like, well, I'll just like show the proof and then I'll do it later. So currently you have A is equal to A, B, C, D, right? And we want B is the sum of the second column A and the K times the first column. So that means B equal to A and then B plus K times A and then C and then B plus K times D. Oops, is not B plus K times D. That is a mistake. This is D plus K times C. And so determinant of A was AD minus BC. Determinant of B is equal to A of D plus KC minus C of B plus KA. But this is equal to AD plus K times AC minus BC minus K times AC. But these two terms cancel out, so this is still equal to AD minus BC. And so that's why determinant A is equal to determinant of B. And we can move on. Okay. So now we're trying to find the inverse of a matrix. So basically, the inverse of a matrix is, as shown, is A times A. So given a matrix A, it's A times A minus 1 is equal to A minus 1 times A is equal to identity matrix, which is going to be 1, 1, 0, 0. And so for 2 by 2, we have that the the inverse matrix you can find is actually just equal to this. And this is quite easy to prove. Like, do I want to prove it? Oh, sure, why not? So if we just write it out, so I'll move the 1 over determinant A to the front. But we know that determinant of A is AD minus BC. And so, and then times the, oops, yeah. So this is, you can start multiplying it out. And it turns out all the, I mean, this note, it's not AD minus BC, sorry. It turns out here, for example, AD minus BC, you get AD minus BC because you have this A and this D. And then you have to minus BC is from the B and negative C here. And this one, it turns out it's equal to 0. The reason is that you have A, so you have a negative AB and then you have a plus AB term. And it turns out it's going to be this. And so this times, and then we have to multiply by 1 over AD over BC. So this gives, and that just gives 1, 0, 0, 1. So does that make sense? I think we can move on. So yeah, we have these two examples. And just don't, in case you don't remember the formula for the matrix 1 over the determinant of the matrix times Okay, so for this problem, for the first one, we can first know the determinant of this is equal to 3 times 1 minus negative 1 times negative 2, root 3 minus 2, which is equal to 1. And so now we can just plug this in. So it turns out it's 1 because it's D and D. And so one is B and the negative piece is 1. Third one is negative C. And negative C turns out to be equal to 2. And the last one is A. And so it's 1 over 1, but that's just equal to 1. So it's just this. And second one, if we try to compute the determinant, is 15 times 2 minus 3 times 10. That turns out equal to 0. But you can't divide by 0. So this is a very important fact about inverses, is that if the determinant of a matrix is equal to 0, then you can't have an inverse of that matrix. The inverse of that matrix will not exist. And that is very important to remember. And we can continue. And yeah, and this is some bonus dark magic. Also, we should draw a line here in order to not confuse this with this. So if B is equal to K times A, then determinant of B is equal to K times determinant A. This is like a very simple exercise we did because like we just simply, for example, if we had A, B, C, D, and then KA, KB, KC, KD, then like this is just going to be K squared AD minus K squared BC. There's K squared times. And then so the second one, this one holds for any matrix. And then this one, actually, this one's very simple proof. You don't even have to like do anything involving matrix. It's just that AB inverse times B inverse A inverse. Well, like that was if you expand, I mean, like, well, not inverse here. It's just AB times B inverse A inverse. So the B and the B inverse cancel out, so it's A times A inverse and it's equal to 1. And this works because like it's not equal to A inverse B minus inverse. And the reason is that because, as we said, multiplication is not commutative. It's like you can't just directly cancel the A and A minus here because you have to like, because they're not directly next to each other. Our second thing is I mean our last one is this, except I think we already proved this in the earlier example, so I won't go over it anymore. But it's very useful because like if you want to calculate a determinant of something like and it has a lot of large numbers, it makes a bunch of stuff cancel. Because the idea is that you just take one row and and then you subtract that row or add that row to another row. And you can do that multiple times. Oh, interesting. We might not have gone over this actually. Okay, wait, I'll like explain this. So like let's say we had a matrix A, right? And we multiplied to a vector. That's V. And we let the vector V be xy, and the vector the A is A, B, C, D, right? Right. And now let's say like we multiply this. Then we have AX plus BY. The product would be A times V is equal to CX plus DY. And let's say so if this is equal to some like vector, let's say MN. Oops. MN, right? Then like you can notice that this is a system of linear equations. Like it's very similar to this. For example, like it's a similar system of linear equations in terms of X and Y. But like then you can multiply by the inverse of A. So if we multiply A inverse on both sides, what we have is that V will equal to A inverse times MN, right? And so that means that like given you have such a system of linear equation, what you can do is you can take the inverse of this matrix. For example, this matrix represented 2, 1, 1, 1. You take the inverse of the matrix and multiply by this vector, which is 8, 5. And so try this. Let's try these two examples. We do not use, for the sake of like learning, we do not use Kramer's rule on this example. Other, like, okay, let's try this. So for example, for the first one, we may notice that the matrix has 2, what, comma, 1, 1, 1, 1. The determinant of this matrix is 2 minus 1 is equal to 1, right? And so now if we plug this into the inverse matrix formula, what we get is 1 over 1, which is still 1. So it's going to be 1, negative 1, negative 1, 2, right? And we will try to multiply this by the vector 8, comma 5. And so what this gives is the vector 8 times 1 plus 5 times negative 1, and 8 times negative 1 plus 5 times 2. And so this gives 3, comma 2. And so that means that our solution is 3, comma 2. And similarly for the second one, our matrix is now equal to 3, negative 1, negative 2, 1. And so now the determinant of this thing is still equal to 1, which means the inverse by the inverse formula is still 1, 2, 1, 3. If I'm Oh wait, no, it's not 1, 2. Sorry, I flipped to 2. It's 1, 1, 2, 3. Right. In any case, it's still we have a 1 over 1 factor, so it doesn't matter. Now we can again multiply this 8 by 8, 4. This is equal to 8 plus 4, 2 times 8 plus 4 times 3 is equal to 12, 28. And so that is the solution to the second one. We can move on to next one. And now we'll just be going over so now we're gonna officially stop learning about matrix. Isn't that so sad? We're gonna learn about ellipses. So ellipses are basically circles that have been stretched. Like this is a circle except it got stretched slightly. And so now it looks sad. But the formula for ellipse is this, right? And so there's like really two types of ellipse, even though like they're really one type of ellipse, which is basically the longer, so like you notice that there's like if you take this one, right? So we can first find some points that lie on this. And turns out you have a comma 0, 0 comma b, negative a comma 0, and 0 comma negative b that all lie on this ellipse. And so it looks a bit like this. And so like there's two like axes. They're the y x and y axes. And so we call the longer one the major axis and the shorter one the minor axis. That's because like one is longer than the other. And there's also these mysterious points called foci, which lie on the major axes. It's like here, for example, the major axis is like the y-axis, where here's the x-axis. But there's like otherwise not much of a difference. And then there's these mysterious point called foci, which like we shall discuss soon. And they have such formula such that the point C is given by point C, so that C squared equal to A squared minus B squared, where A squared and B squared are these two numbers down there. Equivalently, like A is this point and B is this point. Does that make sense? Wait, did you guys go over ellipses? Because I'm not sure. Can you guys like tell me? Okay, that's good. Okay, then we should like in this case we're just gonna do some review. So we're gonna have you guys do this amazing review problem. Okay, I forgot to mention that like for now we're gonna assume that A is greater than B, right? And so then we know that C squared is so if we draw like the one that's center at the origin, right? That this is 0 comma B and this is A comma 0, then we know that two foci are plus minus equal to C, where is equal to A squared minus B squared, right? So it turns out if we have the HK, all that does is shift it. So it turns out the foci are just H plus or minus equals to C, which and so we know C will be equal to square root of A squared minus B squared, and the y-axis doesn't change because it's still a level. So it's this. This is mean A greater than B. Otherwise, you can move this to this side. We may continue the class. So we may do this problem, which might be a bit hard, but it's okay. Okay, for this problem, we have several steps to do. First one we could try, first thing we could try is find the vertex of the parabola with equation x squared minus 10x plus 7.
Find that
And so,
the vertex is 512.
yes, it's gonna be x minus 5 squared plus 12. The vertex is 5, 12. So the ellipse passes through 5, 12, also has foci at 0, 0, and 7, 14, 0. So that means that the center of the ellipse we know already must be 7, 0, because it must be the midpoint of the two foci.
So we have like the equation is like x minus 7 squared.
Silencio, por favor. And so we have we have x minus 7 squared over a squared plus y squared over b squared is equal to what's it called? This thing is equal to 1. Furthermore, we have, because the foci is at 0, 0, and 14, 0, we have that a squared minus b squared is equal to 49, because that is the equation for the length of the foci. And so if we plug this in, if we plug 512 in here, we have 4 over a squared plus 144 over b squared is equal to 1. Multiply a squared b, and so we have these two things that we can solve for. And we wish to find the length of the major axis, hence we want to find a. And so one way you can do this is you can substitute b squared, because we know that b squared is equal to 49, 49, I mean not 49, is equal to a squared minus 49. So 4 over a squared plus 144 over a squared minus 49 is equal to 1. We multiply both sides out, we have that 4a squared minus 4 times 49 equal to 196 plus 144 a squared equal to a to the fourth minus 49 a squared. And then you can want to solve the quadratic if you wish to, because of a to the 4. I hope we did not make mistakes. Who knows? (197 a squared plus 196 is equal to 0. That means that a squared is equal to 1, or a squared is equal to 196. So that means that a is equal to 1 or 14. We want a to be positive. And it turns out that wait, no, something is clearly wrong. A is not clearly not 14. Oh no, okay, a is 14, yeah. And so a is 14. That means the length of the major axis is 2 times 14, which is going to be equal to 28. And the reason we cannot have a equal 1, because then we have that a smaller than c, which does not work. Hence, that is the answer, and we are done. And we may have a break.
I hope you're all back from break. I guess now we'll start the second half of class. So let's start by doing one last review question for ellipses, and then we'll start doing hyperboles. And DM me your answer. The purple, my purple PFP account. Okay, so I'm gonna go over this question now. If I can get my okay, so for this question, we can like complete the square here. We can move everything to one side first. Then completing the square means adding a 64 here, and adding a 256 here. So you also add them on these on this right hand side. Well, why did I have 56, bro? Wait, sorry about this. So adding a 64, adding a 256. So once we add these, we get x minus 8 squared plus y minus 16 squared equals 320. This is just a circle with radius square root 320, so the area is just 320 pi. Any questions? Now, let's move on to hyperbolas. So it's defined by a set of points whose like absolute difference, which is like distance 1 minus distance, is equal to like a fixed number. And the 2 points are called the foci. So like over here, as you can see, it's F1 and F2 labeled here. And the thing here is that like any point on these like two blue curves, like their distances to like F1 and F2, like the difference is like constant across the whole curve. And then here like some terms you like it's helpful to know, like it's probably like not tested on much. So branches are like these blue curves you see here, but branches like basically like just like not used at all. It's still good to know, I guess. The conjugate axis is like the line perpendicular to the transverse axis. The transverse axis has the foci and also the center and also the vertices. And the vertices are like the points closest to the center, like over here, as you can see. Conjugate axis is just perpendicular to transverse axis and also passes through the center. So that's that. And then now for equations. This is the equation for a hyperbola centered at HK. And you might notice it's pretty similar to the ellipse one, but just with a minus sign instead of a plus sign, which I'll prove it later. And then asymptotes are y minus k equals plus minus b over 8 times x minus h. And here's the proof right here. So the asymptote is like defined as like the limit of x to positive or negative infinity when x is taken to positive or minus infinity. So over here, well, we can first like from this equation, we can first like move it so like we can get like x minus h squared over a squared minus 1 equals y minus k squared over v squared. Right? And then from here, we can multiply both sides by b to get that this is also going to be multiplied by b. And now we can b squared. Now we can square root this, like square both sides here, and then add k to both sides. So then we get this. And then now if you take the limit for a definition of an asymptote, so take limit of the left-hand side, you get this. And then for right-hand side, it's just limit x to positive or negative infinity of this blob over here. And what you see over here is that as x reaches infinity, right? This thing gets infinitely large. So this thing becomes infinity. And a is still a. So this just becomes like 1 over infinity squared, and then that's basically just near 0. So this becomes 0, and then you just get that's 1. So then you just can cancel this whole thing out and just replace it with 1 as you take the limit, and now you can just like simplify into this. Any questions with that? Wait. Okay, now let's do the actual equation. So it's mostly on here, so you can first use definition. So like if the 2 points are two foci are 0, C and 0, negative C, then you can use distance formula to get this first equation, because that's like the distance from like x, y to 0, positive, I mean negative C, and that's 0, positive C, right? And then you can square, yeah, you can like move this thing to over here to get the second equation, and then you can square both sides to get this, and then you can expand. So these two cancel out obviously, and then x plus c squared minus x minus c squared, you can cancel it out for a 4xc, and then cancel out the 4. And then as you can see, we didn't get this by rearranging the terms again. Then square it again, and you get this equation. Now you can just expand it. So c squared minus a squared times x squared minus a squared minus squared equals a squared c times c squared minus a squared. And now to substitute back in b squared equals c squared minus a squared to get this equation. And yes, this is assuming the center is 0, 0. If it's not, you have to shift it as mentioned above here, like to h and k. So it's not a center. And also here, we also like see over here with the substitution that the foci, which is going to be 0 plus minus c, the c is just defined as a squared minus b squared. Oh dear. Okay, any question on this? Okay, now let's review the y-axis hyperbolas. So for y-axis, it's basically the same thing and it's basically just symmetric except the x is now a y. So for a y-axis hyperbola centered at hk, you still once again have like x minus h squared and y minus k squared. But now the only difference is that like you swap a and b, and now it's minus x minus h squared over b squared instead of minus y. And then similarly, the asymptote is also like the similar form to up here, as you can see, like this thing. So that's that. And with this, you can also like derive the formula of the foci. So since the center is hk, then the foci is just hk plus minus square root a squared plus b squared, if I'm not wrong. So when solving a problem with hyperboles or hyperbolas, you should always check if it's minus x or minus y, because or else like you could get the whole transverse axis wrong, and that just like ruins the whole problem. Any questions on all of these? I know it was a bit harsh, so I'll go back here and you can take a look at this again. Wait, it's down here actually. Now let's do some problems. So let's try this one first. You can ignore this last part, just saying. This last part, don't do it. But I guess also find the center. I was asked to scroll up. Sorry about this. Now I'll go back to this. I'll also add here to find the vertices. I'm gonna go over this again because I don't think people really like got some things. So just right over here, this is a squared and b squared, but this is only b over a. Because like when you think about it, right? Like when we see up here, like this whole thing isn't a square root. So when you derive the asymptote formula, it's only b over a. But this is a squared and b squared because like it's after a square root. And also just like clarifying the misconception here. The foci are not the vertices. So like the vertices are like of these branches you see over here is the tip over here, like the part that's closest to the center. But the foci are like not the vertices. Instead, foci are the points, like the 2 points where like the hyperbola is defined based on. It's the 2 points that like every single point on the hyperbola is equidist. It's like has a same like difference of distances too. So here it's gonna be this one and this one. So the vertex is on the hyperbola, but the foci is basically never on the hyperbola itself. So now I'll go over this. So this is a squared, this is b squared, which gives you that a is 4 or plus minus 4, b is plus minus 2, though it really rarely matters though. Asymptotes are simply just going to be y equals plus minus half x. Write that later. Y equal plus minus half x. And as for the foci, we get c squared is a squared plus b squared, which is 20. So it's just going to be plus minus 2 square root 5, which is square root 20 and 0. And as for the center, which is quite obviously 0, 0. And lastly, for the vertices, it's going to be plus minus 4, 0, because a is plus minus 4. Any questions on this? Okay. Let's give it a try on this question now. And point slope form is fine for the asymptote. And now I'll go over this. So the center is just gonna simply be 3, 0. As for the asymptotes, let's calculate A and B again. So A is plus minus 3, B is plus minus 1. So asymptote is just gonna be plus minus 1 over 3 times x minus 3 equals y. And yeah, that's for asymptotes. And vertices are just going to be 3 plus minus 3, 0, which is going to be 0, 0, or 6, 0. And foci, we can find that c squared is going to be 10, so it's just 3 plus minus square root 10 and 0. So that's for this question. Any questions? Okay, let's do the next one now. This one's a bit harder, I think. I'll give you more time on this one.
Wait, is that also find center asymptotes,
Yeah,
vertices, foci?
the same thing as above. Center, asymptotes, vertices, and foci. Should write it. I'll type it, I guess. I'm gonna go over this now. So we can first complete the square to I'm just gonna first delete this message. So we can first complete the square to get x plus 6 squared minus 3 y minus 3 squared equals negative 12. And that's because I have a plus 36 here and a minus 27 here. So from this, we can then like change it into the hyperbola form, which involves making this positive 1. So then we have y minus 3 squared over 4 minus x plus 6 squared over 12 equals 1. So from this, then we can get everything now. So the center is just going to be negative 6, 3. Remember that this is a y hyperbola. And then the vertices are going to be negative 6 and 3 plus minus 2 because over here our a is going to be 2. And then for the foci, 4 plus 12 is 16, and square root of 16 is 4. So foci is just going to be negative 6 plus minus, wait, not plus, plus minus 4 plus 3. And then for asymptotes, we have y minus 3 is, the ratio is going to be 4, square root of 4 over 12, which is plus minus 1 over root 3. And x plus 6. You can also write this as square root of 3 over 3 if you care, but I don't really care, so yeah. Any questions with this? Okay, then let's move on to the next few. Next few are much simpler. And let's do these two all at once, because let's do these two at once. And now I'll go over these. So for the first question, the center is at 0, 0, so we don't have to worry about like x minus h or like y minus k, those things. And then the focus is at 3, 0. So this means that a squared plus b squared is going to be 3 squared. The vertex being at 1, 0 means that it is an x-axis hyperbola, so it's going to be like x squared over a squared minus y squared over b squared format. And then vertex at 1, 0 means that a is 1. So we can write this as 1. And then I would just solve for b squared. B squared is 8. So with that, we can just write. So this is our hyperbola. X squared over 1 minus y squared over 8 is 1. And now as for this problem, the foci being at -5 and +5 means that we have a squared plus b squared equals 25. And since the midpoint of the line segment of the two foci is the center is just 0, 0. And then vertex at 3, 0 means that it is an x-axis centered hyperbola. And then we get a squared is 9. So we just get x squared over 9 minus y squared over 16 is 1. Okay, any questions with these two problems? Okay, if not, we can do this one real quick. Wait. And now go over this. Once again, the center is the midpoint of the two foci, so center is 0, 0. And then asymptote being y equals -x means that a over b is -1 or just 1. So now we get that a equals b basically. With this, we can also or a squared equals b squared is more accurate. With this, we can also get a squared plus b squared is 4 squared, which is a 16. So a and b are both, or a squared and b squared are both 8. So then we could just get that x squared over 8 minus y squared over 8, not 0, what am I doing? Equals 1. Any questions with this? Okay, if not, we can do the real world example. Let me clear this. And I know you can do this with like other methods, but please try to use hyperbolas. And if you guys don't know yet, 1 mile is 5 to 80 feet. Yeah, I'll do this one right now because the end is like a bit hard to like do without a calculator. Or should have been possible, you might say. Oh, right. Okay. So we can just like let A be standing at 2, 6, 40, 0, and B be standing at negative 2, 6, 40, 0, right? So then the center is 0, 0, and A and B are the foci. And now this hyperbola with A and B as the foci and a difference of 1100 feet is gonna be like the like it's like the group of all points where like the thunder can strike. Like it can be from. So then we can find out that in our like equation we have that A is 5, A is 2, A is 1100, so A is 550. And then we also have that C is 2640, because C is like the foci. distance to the center. So now with this, we can calculate out b squared, and eventually you can like do the calculations, but you get b squared is 6,667,100, and then a squared is like 3,025,00. That's doable because a is just 55 times 10. That's actually doable. And now with these, you just write it as a hyperbola. It's something like x squared over 3,025,00 minus y squared over 6,667,100 equals 1. And then you just plug in x is to 640 because it says that it's like right north of A. So just plug in x is to 640. And then you can get y. Okay, any questions on this question? Okay, if not, we'll do one last challenge question. And since time's out, I'll just do it like right now. So, intersection point means that if the x-coordinate of y equals ax is 0, then y is also 0. So that means this passes through 0, 0. If we plug in 0, 0, we get that 3 squared over a squared minus 0 over 1, or b squared is 1. This is just 0, so you get a squared is 9. Right? So then you can like write this as x minus 3 over squared over 9 minus y squared over b squared is 1. And now you can plug in x, bx to find the x coordinates, right? So when you plug in x, bx, you get y as bx. So y squared is b squared x squared. And the b squared cancel out. So then you just get that x minus 3 squared over 9 is 1 plus x squared. And then multiply the 9 over here, 9 plus 9x squared. And then you can solve this. After simplifying, you get 8x squared plus 6x equals 0, which gives you x equals 0 and negative 3/4, I believe. Okay, any questions with this? Okay, if there's no questions, I'll tell you guys the homework. The homework is for matrices, we have these. Then challenge problems on AOPS, Precalculus. And then for hyperbolas, we have these. I'll post them later on Google Classroom, so it's fine if you don't note them there right now. And if there's no more questions, I guess that's it for this week's class. And thank you for attending this Pal4pal Precalculus program. And see you. Bye.